We have yet another presentation, which is a logical continuation of Michel Tonon. It will be made by the company of Racurs and Technology 2000 jointly evaluated the Spot 6 data, and we're going to make a presentation about that. It will be the commercial director of the company Racurs, Aleksandr Chekurin, who will be making the presentation.
This has become a tradition for me to make presentation right before lunch. It gives me special pleasure to speak right after Michel about good quality of Spot 6 images in particular. So my presentation will be about accuracy and interpretability properties of images from Spot 6. Two companies, Racurs and Technology 2000, performed accuracy and interpretability properties respectively. The presentation will include two parts, naturally. The first on accuracy, the other on interpretability. Let's start with accuracy assessment. Here you can see basic experiment information. There are three models you can use to orient images: rigorous models, RPC models, and universal push-through models used when there is some missing data on sensor or movement. Rigorous methods were not applied based on motivation leave well alone. I mean, we believe that RPCs provided by Airbus Defence and Space are of good quality, and they deliver the same accuracy results as rigorous models, but they're much easier and simpler to process. Raw data, original data, included a triplet of Spot 6 images. 23 points were used. Experiments were carried out using different number of ground control points. Mostly we used RPC refinements, so we removed bias. This is more information on test data set received on August 16. This is triplet for the Bashkortostan Republic. These are descriptors for ground points in planimetric at less than 1 meter and height less than 30 centimeter area. And these are the experiments we carried out during image adjustment. Mostly it's RPC. In some cases complemented with universal methodology. In fact, it will take several dozens of spreadsheets like that to report full results. So I'll give you just one example. We used different numbers of ground control points. Of importance is the top line, which shows the accuracy, orientation accuracy with 25 points and 3.8 meter RMSE, which we believe is a good result. Airbus Defence and Space specifications indicate 30 meters, if I'm not mistaken. Of course, we performed the same experiments with other data sets And these are some of the conclusions we produced. Planimetric accuracy of supplied RPC without ground control points ranged from 3.8 to 5.3 meters. When one point was added, the accuracy increased to 2.2 to 2.7 meters. When 4 GCPs were added, accuracy reached 2 meters, and further increase in the number of GCPs did not improve the accuracy. Universal methods delivered very poor accuracy results. Now let's move on to triplet orientation. The same methods were used. We experimented with various things, but I wanted to highlight one of them, and that is altitude orientation based on 4 checkpoints. The RMS error was less than 1.5 meters, which is the first time in our experience such high accuracy with such reliable reference material. This triplet orientation did not have any points, but when we added tie points, it did not affect the result. This is the conclusions on orientation. So as you can see, the planimetric accuracy was 3.9 meters, RMSE, and vertical accuracy 12.7. The difference between adjustment with or without tie points was hardly noticeable. The best result was achieved when using 4 GCPs, in which case the error was 1.4 meters, which is an extremely good result. Adding more GCPs did not improve the accuracy, and the universal methods were not particularly suitable in this case, as in the previous one. We selected 3 individual stereo pairs, which were then adjusted. The stereo pair from the edge images showed basically the same results as the triplet itself. The stereo pair with the nadir image, because of its poor quality, showed poorer results. Now let's talk about interpretation properties carried out by the company Technologia 2000. It was a pretty chunky piece of work. It's difficult to provide a detailed account, so just a few pictures and main conclusions. The area of interest here is the city of Ufa, with area 2,600 square kilometers. This is a large city. Well-developed road network, diverse vegetation, a lot of hills. Estimation of interpretation properties applied to 1 to 25,000 maps. The methodology was to visually determine completeness of the map. Ortho photos, 40 centimeter ortho photo from aerial photography was used, and 1 to 10,000 topographic map. Now let's go over the map's elements, make a few remarks. Detection of reference points of state and local geodetic networks is nearly impossible. Only 2 out of 24 were caught. Displaying hydrography and waterworks was no problem. I mean, water reservoirs, continuous water line, some narrow rivulets, narrower than 5 meters, especially if they're hidden under the forest canopy. These ones caused certain difficulties, so some field inspections were necessary. Dams and bridges are easily detected. Wells are not easily readable except for fountains with a fairly large diameter. Settlements and buildings are read well. Individual houses, industrial sites, cultural sites cause no difficulty. But as always, additional materials are needed for some of the sites to determine their purpose. Ground pipelines were well handled. 75% of those above ground were easily identified. Power transmission lines can be seen only based on the frame, mostly made of wood, but the ones made of ferroconcrete are not so good to read. Vegetation causes least difficulties, and detection of main features of the relief were no problem. You can see everything clearly. So the main conclusions on interpretation properties. These images are quite suitable for creating or updating topographic maps of 1 to 25,000 scale. Most of the objects can be recognized in single space images, and stereo allows for recognizing steep banks and embankments, as well as measuring relative heights of objects not lower than 2.5 meters. Pipelines and power lines often require involving additional materials. And in order to determine the type and supplementary characteristics of the objects, like their purpose of buildings, surfacing of roads, construction material, and so on, you need additional materials to have a complete topographic map. And at the end, I'd like to express acknowledgement to Airbus Defence and Space for the materials provided to us. This has become a tradition for our conferences to share with you results of testing. Last year it was based on Pleiada. I hope we will continue to cooperate with Airbus Defence and Space, and we will be telling you about their great properties. Thank you very much. I can take your questions now or later. I think we will be interested in processing data from other satellites. If Chinese colleagues provide us with information, we will process them as well. If there are no questions, we'll have lunch break now. We're a little bit late, so let's get back at 2:10. Thank you, Alexander.